everyone. Here once again we go with the hybridization calculation with ammonium molecule. So to calculate hybridization, already I have said you in the previous video, we need to make use of valence electrons. So nitrogen is having 5 valence electrons and number of nitrogen atom in ammonium molecule is 1, plus hydrogen atom has valence electron is 1 and it has 4 hydrogen atom attached over here. So 1 into 4 is equal to, since it's a positive radical, we carry a positive charge, so this is equal to +1. Okay, so normally in mathematical calculation we bring this towards the left hand side and make it as an equal to 0. Thus we can see the simplification. 5 ones are 5 and 1 fours are 4. When I bring this side, it is -1 equal to 0 as per the hybridization calculation. So my answer on simplification, I used to get 4. As my answer is 4, you can look into the condition. My answer is in between 0 and 8. So when the answer is 0 and 8, you should divide it by 2. So as I divide it by 2, I get the answer 4. That means 4 orbitals would have been overlapped. So which are the 4 orbitals would have been overlapped? There comes the next argument. So which are the orbitals would have been overlapped? Starting from s orbital, and then we make use of 3p orbital. So 3 plus 1 will be 4. Thus the hybridization of ammonium molecule will be sp3. sp3. Got it? So this is how you need to calculate the hybridization of any molecule being present here. And we have the third example which we can use for the negative radical, which is sulfate ion. So sulfur, the valence electron of sulfur is 6 and we have one sulfur atom attached. It's enclosed in a bracket and they have been attached, plus oxygen also comes into the same family of sulfur, and therefore the valence electron will be 6, and we have 4 atoms of oxygen in this radical. Therefore 6 into 4, which is equal to, it sulfate bears a -2 charge, therefore we'll enter -2 over here. And normal mathematical calculation, we bring this towards 2 towards the left hand side and thus make it as 0 over here. So as we make it as 0 over here, we can see 6 ones are 6 and 6 fours are 24, and when -2 comes towards the left side, it becomes +2. Thus on simplification, I get the answer as 32. 24 plus 2 is 26. 26 plus 6 is 32. So I got my answer above 8. That means that it is in between 9 to 56. So what I need to do, I need to divide my answer by 8. So when I do so, dividing the answer by 8, so automatically you can see I get answer as 4. So when I get 4, you need to know which are the orbitals will undergo combination. So one s orbital will combine with 3p orbitals. Thus you get the hybridization of sp3 molecules. Sulfate molecule is sp3 hybridization. Got it? Yes. Is it clear now? Okay. The next one, very simplest one, beryllium chloride. BeCl2. So as we look into BeCl2, beryllium comes under the second group, so it is having valency 2 and we have one beryllium atom attached, plus chlorine comes under halogen family. All halogens, we know we have 7 as their valence electrons, so 7, and we have 2 halogen atom attached over here, so 7 into 2. So since this molecule carry no charge, so it is equal to 0. So this goes with normal simplification. 2 ones are 2 plus 7 twos are 14. So thus my answer is 16. So when I get my answer as 16, it is above 8. So I need to use the second condition for my calculation. So when my answer is above 8, that is 9, between 9 and 56. So what I need to do, I need to divide it by 8. I need to divide my answer by 8. So as I do divide by answer by 8, so I get the answer as 2. So which are the orbitals will undergo combinations? So when I look into that concept of combinations, I combine one s orbital, and totally I have used only 2, so I will combine one of the p orbitals. Out of 3, only one p orbital is combined, that is px orbital is combined. So that's my hybridization existing in beryllium chloride is sp. That's the hybridization existing beryllium chloride is sp hybridization. Got it? Now here we go with one calculation for you, how to calculate the hybridization of phosphorus pentachloride. So we know how many valence electron is present in phosphorus. So phosphorus will have 5 valence electrons. Phosphorus will have 5 as the valence electrons present. And how many phosphorus atoms are present here? 1. Plus chlorine, normally we know we have 7 chlorine. Chlorine comes under halogen atom, so chlorine will have 7 as their valence electrons, and we have 5 chlorine atom present. Since there is no charge, we'll be making it as equal to 0. So 5 ones are 5 plus 7 5s are 35. So when I do the simplification like this, what is the final answer I am getting? 40. I got the answer as 40. So 40 in the sense, as per my condition, it is avoiding the second one, so above 8. So 40 means what I need to do? I need to divide my answer by 8. So when I divide my answer 40 by 8, so when I divide 40 by 8, what is the answer? It is 5. So 5 in the sense, 5 orbitals will be combined. 5 orbitals would have been combined. Which are the 5 orbitals? Don't take directly the d orbital. We should go orbitals with lower energy level. So I should get my answer as 5. So which are the orbitals would undergo combination now? One s orbital would have been combined with 3 p orbitals. On combination, I'll get only 4, but we have get the answer as 5. So one of the d orbital will be helped over here to undergo overlapping. Thus I will be getting the hybridization answer as sp3 and d. So this is the hybridization what I need to explain over here. So when I count the powers, I should get my answer as 5. So 3 plus 1 is 4 and 4 plus 1 is 5. Thus hybridization can be calculated by this way. So this is way to calculate the hybridization of a molecule. Is that clear, children? Thank you so much for watching.